Hi there, Year 8, and welcome to the second part of our lesson on Hooke's law. Today we're going to be doing the practical experiment. Now it is important that you get a chance to do the practical experiment. This is one of the things that we like to do. And so what I'm going to do is say, if you can't do it, or you choose not to do it, that's fine. Use my results, draw the graph from my results, and have a go at the review and reflect questions. You can still do all the work just with watching the video. However, if you are a student who wants to take a risk, if you are a star and you're going to get the star, you're going to do the experiment yourself and do the graph from your results. Okay, so the first thing, we're just going to remind ourselves what Hooke's law is. Now, Hooke's law, I'm going to read this from where I've written it down so I don't get it wrong. Hooke's law says the extension of an elastic object is directly proportional to the force applied. We looked at this yesterday. We saw our elastic object, we saw me apply a force and extend it. Nice and easy. And we also looked at the mathematics of that. F equals kx. I did a couple of sums for you and you had a go at doing them yourself. So today we're going to do the practical on that. And instead of me just going, oh yeah, I'm just applying a random force and extending things, we're going to apply a specific force. And that specific force is going to be weight. More specifically, the weight of a penguin bar. Okay, so I know, because I've got the wrapper here, so I know that this penguin bar is 24.6 grams. Okay, I'm going to write that down so I don't get that wrong. 24.6. Okay, and I'm going to be adding one of these little masses into a cradle and seeing how long this hairband extends. Okay, you can do it yourself if you like. First of all, though, we're going to discuss our variables. So our independent variable, what are we changing? What am I doing? I'm going to add masses to my hairband. So I am adding a force. I'm adding weight. So my independent variable, yeah, you've all got this. You're all writing it down. My independent variable is going to be the force applied or the weight added. Weight is a force. It doesn't really matter which one you use. What's going to change? I'm going to measure something once I've added my force. So what am I going to measure? Yeah, you didn't need that hint, did you? It is indeed the length of the hairband. So I'm going to be measuring my dependent variable, measuring the length of this hairband. Okay, what control variables do I have? What do I need to keep the same? I'm waiting for some ideas and you're not speaking to me. You might be, I don't know, but this isn't a live recording. So at the moment, you're not speaking to me. I want you to try and come up with at least one thing I have to keep the same. And I want you to write that down. So can I switch between rulers? Could I measure it and then maybe ask for my son to measure it? Anyway, pause the video and write some stuff down. When we restart, I'm going to show you how to get set up. Okay, I'm assuming you've paused now and welcome back. Here we go, let's get set up. If you've got a coat hook or something like that, feel free to use that. But I'm going to assume that people have next to nothing at their home. Okay, you don't have any coat hooks, you don't have springs, you don't have 100-gram masses or anything like that. So I'm just using stuff that I can find around the house. Okay, and one thing I can find is my son's t-shirt with a coat hanger. And what I'm going to do is the hook twists on this one so I can face it forward. I'm going to take this and hang it over the curtain rail. Okay, and then I'm going to add some pegs. Oh, this is a bit of a dodgy peg. Oh well. Just to hold it in place. One peg, two peg. Okay, so now I've got a nice hook about at my eye level. Obviously your tops are going to be a little bit longer than my 3-year-old's top, so you can move yours move yours up or down so it's about at eye level, because it's nice and easy to hold your ruler here and take a measurement, so you don't have to crouch down, you don't have to hold it up here and try and get it. Okay, so try and do it about at eye level. Okay, you will then need an elastic object, elastic band, hairband. If you've got a spring, you can use that. But how can I attach things to a hairband? Yeah, that's not working so well, is it? So what I'm going to do is take a lightweight mask and make a cradle out of it. Okay, if you get your loops for your mask there, yeah, and pop the hairband through like this. Okay, I'm hoping that you can see this nice and easily. So the hairband goes through. I'm then going to loop the hairband through itself and just pull it tight. Okay, so now I've got a cradle with a lightweight mask. Obviously the lighter the weight of the lighter the mask, the better, because you don't really want to be measuring the mask and having that taken into account too much. And I'm just going to pop that on the hook there. So at the moment, I'm going to say I've not added any mass. I'm going to ignore the mass that is the mask. Okay? And you should have a table like this on the worksheet. Okay, so I'm going to write in, we have 0 chocky bickies, which means a mass of 0. And because force is your mass times by gravity, anything times by 0 is 0. And I'm going to do that in red. And we're going to come back to why I'm doing that in a different colour in a minute. Okay, next thing, dependent variable. I've just realised, I hope that you could actually see me when I was stood there. Dependent variable. Now, be really careful. You can either measure it from the top of the hairband to the bottom. You can measure it from the hook to where it's tied. Okay, so there's lots of different start and stop points for measuring. Whatever you do, you have to control it. You have to do it the same for each one. So I'm going to measure it from the top of the hairband up to where it is on the mask, and that is 62 millimeters. But just to make sure that you can see me, I'm going to write it over here. So my length of my hairband is 62 millimeters. It hasn't been extended. It is 62 millimeters. It has not extended. So the extension of my hairband is going to be 0 millimeters. You might have noticed I wrote in something a little bit more than that. I'll come to that in a minute, okay? So, next thing, I'm going to add some mass. I'm going to add just under 25 grams. I'm going to add 1 penguin, okay? And I'm going to just pop it in this nice little mask cradle here. And what should happen is my hairband should extend. Let's measure it and see if that happened. So 1 chocky bicky, and my extension is now, oh, that did work, excellent. It's now 65. So my length of my hairband is 65. Okay, I'm just going to run through this and get the results really quickly, and then we're going to play around with the results and analyse it. So at the moment, we are just using number 1 and number 4. Okay, so the number of chocky bickies, 1, 2, 3, 4, and so on. And we're just going to measure the length of the hairband at the moment. We're not going to do anything else. So let's get some more chocky bickies. Always a good thing. We always need more chocky bickies. Okay, add in chocky bicky number 2. Now I said I wanted this to be proportional. We did say that the extension is proportional to the mass. What does proportional mean? Because I didn't really go into this yesterday. I wanted to leave it for today. So proportional means that if one thing happens, then the other thing happens at the same rate. So if I were to go on a bus and the ticket was £2, if I had 2 bus rides, I'd need £4. If I needed 3 bus rides, that would be £6. Yeah? Same as if I went to the shops to buy my chocky bickies and they said, oh, penguin, that's 50p, please. About 50p for a penguin? Are you kidding me? Because, yeah, I'm really cheap. So 50p for a penguin. So how much would this experiment cost me? Well, at the moment, I've got 2 penguins in there. The cost is proportional to the amount of penguins I'm buying. I buy 2 penguins, that's going to be £1. This is a really expensive experiment. I'm really glad I don't buy chocolate biscuits from that shop. 50p for a penguin. Anyway, so we want our extension to be proportional to the mass. And we're going to see if it is. So, at the moment, we have now got, oh, this is beautiful. This is 68 millimetres. So I'm just going to pause it here and do what this proportional thing means. Okay, so I'm just going to come back. Okay, so these are my results so far. And if we can calculate the extension of the hairband, if we remember, we've started off with 62. So we're now saying 62 is 0. All we need to do is minus 62 from each one. We've got to take away the starting length of the hairband. Okay, so 65 minus 62 is 3. 68 minus 62 is 6. So for every chocky bicky, we are getting 3 millimetres longer, and that's worked for 2 of them. Let's see if our third one gives us another 3 millimetres, which should take us up to 71 millimetres. I'm really excited to see if this works. Okay, I've got my pen, I've got my notebook. Let's see if it works. All right, yeah, I've got 2 in there. Let's add a third one. Okay, 3 chocky bickies. Let's see if we've extended 3 lots of 3 millimetres. Let's see if we've extended 9 millimetres. This works, I'm going to be so happy. We've got it. Oh, 72. So close, so close. But that's okay, that's okay. Let's see what happens when we add a 4th chocky bicky. Is it going to extend 3 millimetres again? Is it going to go for 4? Is it going to go rogue? I'm not quite liking this going rogue. We're reaching our elastic limit if it's going rogue. A bit more on that when we do talk about the graph. So let's measure it again. And we've got, yeah, we're definitely going rogue. We've got 79 millimetres there. I'm just going to add a 5th chocky bicky just because I can do. You know what, as it's a penguin bar, let's go for it. What do you call a penguin with no eye? A penguin. I love penguins. So anyway, let's add our 5th penguin and see what happens. Here we go. 91 millimetres. Okay, so let's take you off. I'm very tempted to stop the video and just eat a penguin now, but I'm going to be good. I'm going to finish my video and then I'm going to eat a penguin. Okay, so all we need to do now, come and sit back down. is we're going to do a few little calculations using this. Okay, so the first thing we need to do is finish calculating the extension of our hairband in millimeters. Okay, so we're going to subtract 62 from all of them. So that would be 10, and then 17, and then 91 minus 62 is a whopping big 29 millimeters. Okay, so once you've done those sums, we also need to calculate the mass. Again, the mass is proportional to the number of chocky bickies. One chocky bicky is 24.6 grams. So that means that 2 chocky bickies is going to be twice that amount. Okay, so that's going to be 49.2 grams. And so on and so forth. I'm going to do this on my calculator because, yeah, I'm saying so I'm a little bit mixed up today. I'm not feeling tip-top-a-roo. Don't worry, there's nothing too wrong with me. But I just want to make sure I'm not making any mistakes. So 24.6 equals plus 24.6. It is 49.2. 73.8. You know what? This is something I love about science. We can just say, I'm not having the best of days today. I'm going to use a calculator. And there's nothing wrong with that. 98.4. Now, I do know that I'm expecting, if one's about 25 grams, 4 should be about just under 100 grams. So my next one should be just under 125 grams. And it's 123 grams exactly. So I'm not completely checking my brain out and letting my calculator do it all, but it's so nice in science. You can just do that. You don't have to do it all in your head like you do for maths. Okay, so there we go. So we've got the mass in grams, and now we need the force in newtons. Okay, so if we remember, to get our force in newtons, we need to get our weight, and our weight is mass multiplied by gravity. Okay, we did this a few lessons back. So gravity on Earth, we usually assume to be 10. It's actually 9.81, but that's a big number or an awkward number. Okay, so we need to have, so every 1 kilogram is 10 newtons. Okay, because we just multiply it by 10. This isn't in kilograms, this is in grams. So what we need to do is 24.6, and we're going to divide that by 1,000 to get 0.0246. Okay, I hope the lighting's okay and you can see this. 0.0246. Then I times it by 10 because I'm adding in gravity now. I'm timesing it by gravity. And I am getting, I've got a force of 0.246 newtons. Okay. And I'm going to do that all the way down. I'm going to divide it by 1,000 to get it into kilograms, and then times by 10 to get it into newtons. You are quite correct. I could just divide by 100. That would work as well, and it would be quicker. However, for those of you who are like, just divide it by 100, there will be someone going, why 100? Why are we dividing it by 100 now? Where did that number come from? So if you want to do it as dividing by 1,000 to convert grams to kilograms, and then timesing by 10 to add in gravity, that is absolutely fine. You don't have to do it the shortcut way. I can do these in my head now, though, because it is just dividing by 100. 0.492, 0.738, 0.984, 1.230. I just like everything to have the same number of decimal places. Okay, if you need to copy that down, feel free. So we started off seeing a fairly regular extension, but then as we got towards the end, it just went a little bit haywire. And this is called the elastic limit. So what you get, and I'm sure that especially those of you with thick hair and curly hair, you are going to know this. You get a hairband like this, which is a fairly flimsy little one, and you put it on your nice thick curly hair, and after a couple of days it's gone, usually around here. And what's happened is you've pulled it and you've twisted it and you've put it around your hair, and it's had to stay like that all day, and you've stretched it past, you've put more force on that. Your hair is a force to be reckoned with, and it's a beautiful force, and it's put so much force on this hairband that this weak little hairband has broken under the magnificence of your hair. At least that's what I tell myself to make myself feel better about having to go out and buy new hairbands all the time. So we have got this lovely hairband which will break, and we all know that they break around the little grip bit here. Okay, and the hairband breaks because we have stretched it. We have stretched it past its elastic limit, past the limit. We've given it so much more force than it is able to cope with. It's just gone, nah, I'm just staying out of shape now. Kind of like after Christmas when you've eaten too many chocolates and someone goes, hey, we could exercise. And you're like, nah, I'm just going to stay out of shape now. So much easier. Well, that's what the hairband does. It doesn't have the sort of elasticity that your skin has. It's not going to spring back into shape with a bit of exercise. It's going to be permanently deformed, and that's pushed it past its elastic limit. I'm now feeling a bit sad that, penguin bars could permanently deform this thing. Not that my hair, it's designed, it should take my hair. My hair deforming you is just you being wrong. But yeah, I'm glad that I stopped the penguin experiment before you snapped. Okay, so next thing to do. That was a bit far too long of an aside there. Next thing to do, extension of the hairband in meters. We did them in millimeters. A millimeter, remember, is 1/1000th of a meter, just as a milligram is 1,000th of a gram. A milliliter is 1,000th of a litre. So to get it into meters, we are going to need to divide by 1,000 again. So extension of hairband in meters, 0 divided by 1,000. Nice and easy, it's 0. 3 divided by 1,000, 0 point hundredths, tens, units. So 003, it's like thousandths, not units. 6, 0.006. 10, 0.01. And you could put 010. I'm going to be, no, I'm not able to leave it. 17, 0.017 meters. That one looked a bit too 70. And 29, 0.029 meters. Okay, write it all down. You can pause the video and then check your working, but this is my working. Okay, I will just point out as well, the spring constant or the elastic constant for every hairband is going to be different. If you've got one that's really similar to this, you might get a similar spring constant for the small amount of force that we put on it. If you are using a different hairband, and I did have a different hairband kicking around to show you, did I tidy it up? No, I didn't. So if I was using this hairband instead, this hairband requires a bit more force to make it move. It's a bit tougher. So this hairband would have a different spring constant or elastic constant. Okay, so if you've done it at home and you're like, oh, my numbers aren't the same, it could be because you're using a different type of hairband, or maybe you found a spring, or maybe you're using an elastic band. So I don't know what you're using. So I can't tell you that your numbers are right or wrong. I would love to see a picture of you doing your experiments as well. That would make me really happy to know that we can still science at home. Even though we're not together, we can still actually do some science. Makes me happy. Okay, so we've got all this. And the next thing to do is to do the graph. Okay, so I'm going to need to, you've got a graph. I'm not going to say already drawn because you've just got like squared paper and the axes. Okay, and I've not written on the axes because if you're doing your own, you're going to need to do this yourself. Okay. Now, if you remember, we always put the independent variable at the bottom on the x-axis and the dependent variable on the y. If you look up graphs for Hooke's law, sometimes for Hooke's law it's reversed. However, I think it's going to be easier to just do it the normal way and have our independent variable on the bottom and our dependent variable on the y. So independent x, dependent y. Okay, and we're going to do the force on the bottom and the extension up the side. All right, so let's draw this. Do I have a pencil kicking around? Because I'd much rather draw it in a pencil. I do. I'll be back in a second. Just admire the lovely brick wall outside my window for 2 seconds. You know what? My children can always find a pencil and draw all over everything. When I need to find a pencil, can I? No. Maybe I should have been doing this with my children at home so they can show me their pencils. Okay, well, I found a biro. I'm going to do it in biro rather than ink pen just because it will run a bit less. So, force in newtons, I need to go up to 1.3. So if I've got 13 centimetres, yes, I can do 13 centimetres and go up to 1.3. Now just remember that we can't just write down what we want on here. We've got to do it proportionally. Okay, so that word proportional coming up again. So every centimetre is going to be worth 0.1 newtons. Okay, please feel free to draw along with me at home. My spelling, honestly. So I've got force in newtons along the bottom, and you can see that I'm starting to fill it in 0.0, 0.1, 0.2, and so on. And then up the side, we're going to need extension in meters. It's a bit of a faff that it's in meters because we've got to use really, really small numbers now. So let's go up to 1, 2, 3, 0.00. Yep, 0.001, 0.002, and 0.003, and so I've decided to do 4 lines or 4 squares, because you're doing it on squared paper, to be 1 centimetre or 10 millimetres or 0.001 metres. No, so I've put in an extra 0 there, haven't I? That should be 0.01, 0.02 and 0.03. Yes. Yeah. So I've got 1, 2, 3 centimetres. Okay. And I'm just going to finish doing my axes because I really don't like unfinished axes. There we go, nice and quick. All right, so the next thing to do, squared paper is going to make this a little bit easier. Okay, so from my table, I know that 0.246 newtons was 0.03 meters. So 0.246 is there. Okay, so I've just marked it on at the bottom. And 0.03 would be here. 0.003. And where those two meet up, you've got squares to help you. I haven't, so I'm drawing it on. Where those two meet up, I'm going to put a nice big cross. Okay, you can see it here. And then I'm going to do the same for the next one, which was 492 and 0.06. So 0.06 is there. And 492 is there. And across. Okay, so you can do this along real time with me. If I'm going too fast, you can pause the video and do it yourself. But have a go at doing it before I show you mine. Okay? I would pause it, but the last time I tried to pause it, I stopped the video and had to do it all over again. So I'm sorry, you're kind of stuck with me doing this. So we've got 738, which is there. We have got, which is there. And we've got 1, 2, 3, which is there. 10, 17, 29. So we've got there. We've got there, and we've got there. Okay. I'm absolutely fine, by the way, with you putting on little guiding lines in pencil and then doing a cross in darker pencil. Ideally, you're doing it in pencil. If you do end up doing it in pen, not the end of the world. Just do it really faintly for your marker lines, please. Okay, and I am done, and it looks like this. So the next thing to do is a line of best fit. Now, a line of best fit should be a line, and it goes from 0 through these lower ones. Okay, now as you can see, it's not going to quite work out brilliantly like that because this is a curve. And if I was asking you to do a curve of best fit, I would curve my ruler and make it fit through as many points as possible. And so it's not easy to do this holding it up. And it would look a bit like that, but I don't want a curve. Where it curves up is where we reached its elastic limit, where it started to warp and deform. And I don't want to measure that. I only want the to measure the elastic limit. So I'm going to put my line of best fit. No, that didn't work very well, did it? I'm going to put my line of best fit, ideally do it with pencil, through the ones that actually worked. Okay, so if it didn't deform, I would have expected my fourth Chocky Bicky there to be at about 0.0125 meters, so about 1.2, 1.3 centimeters, or 12, 13 millimeters, depending on how you look at it. Okay, so that's where it should be. But what actually happens, I'm going to do this on in blue, is that you do end up with a curve, a lovely deformation curve, and it should be an exponential. So it should be like an x squared sort of graph. I'm going to do a curve of best fit there and just make it. Okay, so I've got my curve of best fit fitting through my 3 lines. You don't have to do this bit, by the way. This is just a little bit extra for it to be exciting. And we can find the elastic point where it deforms, which is the bit where the curve crosses the line. So it deformed, by the looks of this, with a force of exactly 0.7 newtons. So if I put on 0.7 newtons, we would still be within our elastic limit, but after that, the deformation starts. How exciting. Well, it is for me. Okay, so we've got our graph, we have got our table, and we can also label on our graph the elastic limit. Okay, again, that's optional. You don't have to label on the elastic limit if you don't want to. All right, so now for everybody, so all of you will have done a table and a graph, whether it is my table and graph or your table and graph. The main thing I want to look at today is your ability to draw a graph. If you've done the experiment as well, you do get the star, but I would love to see that you've drawn this graph. Okay. There are a couple more questions about reading graphs so that you can do your review and reflect as well. So just take a look, see how you're getting on with it. Review, reflect. If there are any problems, do contact me. I am around on email. And this is the last lesson in forces. We've done it. We have done forces. We are enforced. So, brilliant. We've done our forces topic. We do have some revision lessons. The test will be next week. So we're not springing it on you too early. So you do have a test next week. There are a couple of revision lessons coming up. And hopefully that's taught you everything you need to know about Hooke's law. Don't forget to refer back to the formative assessment sheet. You did get one at the start of the topic, and there is one attached to the lesson today. So if you want to just check that you can do everything in the topic, fantastic. If you're like, ooh, hang on a minute, I really don't remember anything about this bit, drop me a line, make sure that I know that you're struggling with something, because I don't want you to go into the test unprepared. Okay, but as I say, any questions, anything you need, let me know, email me. I will get back to you as soon as I can, and I will, look forward to seeing how you do on the test as well. All right, take care, everyone. Bye.